PCMS Robotics students. This is coming to you on April 23rd, Thursday, April 23rd. It's our second video of our 5th week of remote learning. I'm going to start out by going to the PowerPoint like I usually do. These are the assignments that are currently past due. You can still turn them in for full credit. And in progress book, these are now being counted as missing. They were being marked as excluded. So some of you and some of your parents may not have been able to see them if they were past due, but they're no longer considered excluded. They're counted as missing. So that would be a 0 until you do them, but you can do them for full credit. Tomorrow, Friday, you have 2 assignments due. One is the How Do Fans Cool worksheet. You'll watch a video, a couple videos, and read a sheet on this, and then you'll be able to answer the questions. We still have some students getting 20s and 30s. Everybody should be getting 100 on these. If you're not sure about a question, go back and watch the video and check the worksheet out. The face mask project is due tomorrow. I showed you some examples of those 2 days ago on our Tuesday video, and these are 3 more examples turned in by Princeton students in the past few days. We're adhering to this schedule, Monday, Tuesday, Wednesday, Thursday, and Friday. Monday and Fridays will be an email update going out to all students. On Tuesday, there will be a lesson topic, usually with a worksheet. Wednesday is a Zoom meeting time if you want to meet online. And Thursday, today, will be another project assignment. DIY stands for do it yourself. So anytime you're trying to make up a project and you're looking online, put DIY in front of it, and then you'll find lots of examples of how to do those things. So we're going to be working on a fan project, which relates directly to the lesson we had on Tuesday. Part of this lesson today is also going over the engineering design process. It's something we've talked a little bit about in class. I've had posters hanging up telling about the different steps of the design process. And also the GTT classes, Gateway to the Future classes at the school, at Princeton School, have an engineering design process. It's probably very similar to what I'm showing you today. We start at the top where it says ask. Ask would be identifying or researching a need. So I'm going to make up a need. This is not the need you're going to be responding to, but I'm going to make up a need. And the need is we have mice. We have lots of mice. Looks like they're eating Cheerios in one of our cabinets. And I see 5 of them here, and back here on the right side, it looks like there's 1 hidden. So our problem is we have mice. Next step on the engineering design process would be this yellow image up here on the circle, and that's imagine. Imagine solutions of how you can take care of the mice problem that you have. First thing I would do is run out to my garage, and I have some mouse traps out there for when I need them, and I'd just go to a mouse trap first thing. And through the years, a lot of people have used the Victor mousetrap, but there's been other designs also. Ralph Waldo Emerson, a famous author, once said, "Build a better mousetrap and the world will beat a path to your door." And for probably over a couple hundred years, people have been trying to build better mousetraps. They've come up with snap traps, which is what the Victor mousetrap's like, electronic traps, live catch traps, and glue traps. If you're thinking of snap traps, the one I showed you first, the Victor, that's a snap trap. But lots of people have tried to improve on this design. This is one made out of plastic. It looks like it basically does the same thing as the Victor. But lots of people have tried it. Down here at the bottom of the screen, numbers 1, 2 through 23 are all designed for catching mice, and they're all snap traps. At the top, number 1 through 18, these are rat traps. So all the ones on this page are snap traps. The next category is electronic trap. This is where you just want a dead mouse. You don't want a squished mouse, possibly with blood that you have to contend with. So the mouse goes inside, it gets electrocuted, it's dead, and then you have a dead body to deal with. Some people don't want to kill the mice, so they go to the live catch trap. Both of these are examples of that. You would catch the mouse and take it far away, maybe to a park or out in the country, and let it loose. That way you haven't killed the mouse. And then if you want to get some revenge and punish the mouse, you get these things called glue traps. And the mouse doesn't die, at least not very quickly. They get stuck in the trap and they can't get out. And I guess the advantage of these is you can catch several mice on the same glue trap. So if you were one of the early people making a mousetrap, first of all, you'd have the problem, you have mice, then you imagine solutions to the problems, like I've just shown you examples, then you plan and make a prototype. So whoever came up with the first Victor mousetrap probably would have sketched it out on paper like this one on the top left. Then they would have had to submit it for a design, for a patent. So they needed a refined drawing with the different parts labeled, and they get A, B, C, D, and there would be some printed documentation that goes with this. It tells what those parts are. And then they would build a prototype. So this is a prototype of the first Victor mousetrap. You can see there's no printing on it. It's rough cut. It looks like they used a couple nails just bent over to hold the parts in place. And it's not ready for production, but it's ready to test and try out, which goes to our next step in the design process, which is create. So you test it and you evaluate your prototype. So in this example, we've got somebody sticking an ink pen here, trying it out. They put a design on here. It's not ready for marketing, but it gives you an idea of they're going to be adding a design to this thing. And then on this side, this captures from a video, and it shows the mouse eating the whole piece of cheese, and the trap never went off. So evaluating that design, they knew they had to come up with another way of tripping the mousetrap. And then finally, we come to the fifth step on our design process. We improve, modifying and retesting the solution. So they obviously needed to make some improvements on it, and then they test it, and then finally they go into production. This was what the Victor mousetrap looked like when I was a kid. And you still find some of them that look like this, but they went back to this design process, and you'll notice it's a continuous loop. It doesn't end with this purple square on the side. It keeps going around. So as you're in production making these mousetraps, maybe someday somebody comes up with an improvement. So this was the original production mousetrap. This is what it looks like today. They found out the mice are actually attracted to this plastic. So you can put cheese, you can put peanut butter, or different types of foods on there to get the mouse attracted, but the mice will also be attracted to this piece of plastic. It's also got a different way of tripping. You'll notice it's a little bit more slippery than what they had up here in the metal one on the left. So it's a continuous process, and I haven't seen them make any improvements on this particular type of mousetrap, but I've seen lots of other mousetraps out there. So I'm going to give you a statement of problem that we're going to solve, and the statement is, with the hot days of summer approaching, we need a way to keep cool. So that's the green area on our design process. Your assignment is to imagine, plan, create, and improve upon your design for a fan. The fan can be manually or electrically operated. You will be creating two fans, a prototype, which you'll use for testing, and a finished fan. And the appearance of the finished fan will be worth one letter grade. So you'll notice the Victor mousetrap had printing on it to make it more marketable. So the fan you create, you'll need to enhance its appearance in some way, just like we've done at school in our projects. Then you're going to insert a photo of your two fans on the next slide of the assignment. And this assignment will be due next Friday. So that gives you a day and a week to make two fans. So if you're imagining, you might look on the internet, look up at different ideas. These are some of the fan fold types at the top. The ones on the bottom left are called paddle fans or funeral home fans. And that'll give you some idea to help imagine. Now, this is one that I didn't even think of the other day, but it's made up, it looks like 5 cards. It looks like it was made for a wedding to hand out. It's got a single little clasp there to join the pieces together, and then you just unfold it to turn it into a fan and fold it back up to carry it somewhere else. It looks like on this picture, there's some of these paper joiners, and there's a hole punch, even though you don't need a hole punch to do the project. These are both a paper plate that's been cut in half. They've both been decorated. This one's got a good decoration with the rainbow design. And then they had 2 craft sticks. It looks like these are the big ones, but you don't have to use craft sticks. You could use even sticks that you find outside to put it together. So it's a pretty unique and cool little design I've never seen before. These are the paddle fans. These have printing on them. Looks like this was designed maybe for a baby shower. I'm not sure. Um, but this is another design. Looks like they used a paint stir stick up the middle of it and probably stapled around the edges, but I'm not sure. And there's no one right way to do this. There's a lot of different ways you could do it. And you've probably even made these. This is one I made the other day out of a single sheet of paper. And this is a pretty simple one. So if you can come up with something more complex, it would be great. If you look on the internet, you'll see a bunch of designs that use something like this with two pieces of paper or a single piece cut in half, and you fold each half separately and join it together with a couple sticks. And if you want to do one that's electric, there's a lot of designs on the internet on how to do that. You can make propellers out of plastic you get from pop bottles. The hard part would be finding the motor, but a lot of people have toys where they can just tear the motor out of the toy and then see what they can come up with in designing a fan. So going back to the activity, your assignment is to imagine, plan, create, and improve upon your design for a fan. I'm looking for the prototype that you originally did, and I'm looking for the finished fan. On the last slide of the assignment, as we've done before, like with the face mask, you're going to place a picture of your prototype and the finished fan on the last slide. To add a picture, you need to use the insert menu on this slide. Make your picture large or as big as this slide. So don't make it real small, just blow it up and make it kind of big. So once again, as usual, any questions, you can text me, or not text me, but email me, and you can meet me for the Zoom meeting next week. Hopefully I'll have some examples I can share with you by then. So until next time, stay safe, and I'll see you again next week.